Assalamu alaikum. Good afternoon, everyone. I am Dr. Mirza Salman Beg, Assistant Professor in Pharmaceutics at AIPTC School of Pharmacy. Today we are going to discuss about powder properties. So we will discuss about the concept and method to determine bulk density, tab density, true density of a given powder sample, then formula to calculate derived properties of powder like percent porosity, Carr's compressibility index, and Hausner ratio. Now let us begin with the basics. So density is the ratio of weight to the volume of a given powder sample. But depending upon the method we employ for measurement of the volume, there can be different types of the volume for powder. It can be bulk volume, it can be a tap volume, and it can be a true volume of a powder. Now, depending upon the volume we employ for measurement of density, we have different types of the densities like bulk density, tap density, and true density. In bulk density, the bulk density is the ratio of mass of untapped powder sample and its volume. And this volume include interparticular spaces, voids, and pores. So it is inclusive of all the voids and the pores that are present within the powder sample. In tap volume, although the volume of the voids and interparticular space is included, but the powder arrangement is relatively compact as compared to this arrangement. So the tap density is obtained by mechanically tapping a graduated measuring cylinder or a vessel containing the powder sample. Now bulk density is the weight of the powder divided by the volume of that powder. Now in this case, let us suppose that these are the particles of the powder, irregular shaped particles, which are present in this given volume. So this volume is untapped volume. The bulk volume of a powder is the volume occupied by all the particles. Now tap volume is relatively compact. The tap volume of a powder is volume occupied by all the particles and it is represented by this box. Now this is just to make you aware about how this tap density is determined. So tap density is the weight of a powder divided by the tap volume of the powder. Now experimentally, we take the measuring cylinder. In that we add small quantity of powder, say around 20 gram of the powder. Now whatever volume occupied by this given powder sample is known as the bulk volume. And to calculate the bulk density, we can use this formula: bulk density is equal to weight of a powder divided by the bulk volume of that powder. And what is the tap volume? So to determine tap volume, we simply tap this measuring cylinder couple of times so that the particle gets settled down and we get a more compact arrangement of the same sample, same powder sample. Just there is a decrease in the volume and we can determine the tap density by dividing weight of the powder to the tap volume. So this is the tap volume for the same amount of the powder sample that we have used to determine the bulk volume. Now what is the true density? So true density, that is the solid mass divided by the true solid volume, excluding the void volume of open and closed pores and interparticle voids. So in determination of the true density, the volume we use is a true volume. And this true volume, it excludes all the volumes between all the volume of the voids between the particles or the volume of pores present within the particles, whether it is a closed pores or open pores. And to determine the true density, we use the liquid displacement method. Now, what is a liquid displacement method? So, the true density is the measured using the actual density. The true density is measured using the true volume of the powder sample. Now, what is the true volume of a powder sample? The volume of the particle excluding the combined volume of all the particles, excluding the interparticular voids and pores. Now, in this case, the volume occupied by the particles, which is represented in the blue color shade, the volume of the actual volume of the powder material. Now, how to determine this true volume? So, we use the liquid displacement method. So, this is the specific gravity bottle or density bottle. So, weigh the empty bottle and assign the weight with some letter A. Note it down, the weight of A. Then add the powder sample to the dry bottle. And again do the weighing of this. Weight of the bottle plus powder is equal to B. Again, add water to this powder containing bottle. Mix the powder very well with a small quantity of the water, then make up the volume till the neck, then close the stopper. Let's close the bottle with the stopper and then do the weight, assign the weight C. Now in this case, C stands for weight of the bottle plus powder plus partial water. That means his bottle is not completely filled with the water, rather it is partially filled with water as well as partially filled with the powder. Okay, so that's why I have denoted it with water dash. Okay, where water dash is W dash is equal to partial water and W dash is equal to C minus weight of powder, weight of bottle plus powder. And we can write it in this form, W dash is equal to C minus CB. Then in the next step, empty all the contents of the specific gravity bottle, completely fill it with the water, then do the weighing, assign the weight D to it. So D stands for the weight, combined weight of bottle plus water. Where the water filled in this bottle is equal to W. This is a full water, that means the bottle is completely filled with water only. And W is equal to D minus the weight of water. So W is equal to D minus A. True density is the ratio of weight of the powder to the true volume of the powder. So it is the ratio of weight of the powder to the volume of displaced water, as we have seen earlier. But the volume of displaced water is equal to the weight of the displaced water if we assume density of water to be 1 gram per cc. So the volume of the displaced water is equal to the weight of the displaced water. Now the weight of the displaced water divided by W minus W dash, the true density. So here we can replace volume of the displaced water with this formula W minus W dash, whereas weight of the displaced water W minus W dash, or full water minus partial water, is W is equal to weight of the full water, that is B minus A, and W dash is the weight of the partial water, that is C minus B. And finally, we get the equation to determine the true density of the powder. So true density of the powder is equal to B minus A divided by D minus A minus C minus B. By placing all the values that we have observed for A, B, C, and D, simply we have to place all those values in the formula to determine the true density of the given powder sample. Once we determine the true density, bulk density, and tap density, we can determine various derived properties of the powder. For example, percent porosity. So percent porosity is equal to true density minus bulk density divided by true density into 100. Carr's index is equal to tap density minus bulk density divided by tap density into 100. Hausner ratio is equal to tap density divided by bulk density. Now we can correlate these derived properties of the powder with the flow property of the powder. So for instance, if the Carr's index is less than 10 and Hausner ratio is in the range of 1 to 1.11, then we can make a conclusion that the powder is having an excellent flow property. Now, if the Carr's index is in the range of 11 to 15, then it is having the good flow property, whereas the corresponding Hausner ratio is 1.12 to 1.18. And this table, it provides information related to the flow property of the powder and corresponding Carr's index and Hausner ratio. So these are the references. Thank you very much.